Last time we built a WireGuard a container based on WireGuard, and we created VPN connections to connect internet through VPN. Today we will continue with DNS management, and then if we have time, we will complete the WireGuard example at the end of the WireGuard lesson. There is another example with WireGuard here. So about DNS, we want to manage our own DNS records in our own server. But first, let's try to understand what is DNS and how it works. DNS is a domain translation server. So we have a name, the name of the server, and we want to know the IP of the server, because we can communicate with the TCP/IP protocol. We can communicate if we know the IP address. But IP addresses are not easy to remember, so we assign names to IP addresses so that we can remember them easily. And then we need some way to translate from the name to the IP address. And this task is accomplished by domain name servers. There are many servers around the world that accomplish this task or do this job. And they are organized in a hierarchical manner, like a tree. So there are some root name servers, and then there are some top-level domain name servers. For example, .edu, .com, .org. These are .al, for example, .it, .de. These are top-level domain name servers or domains, top-level domains. And then subdomains of these domains, for example, example.org. And then there may be some other subdomains or the name of a server. So this is like an example. Now let us see, for example, how we can find out. We will try to find out what is the name, what is the IP address for the name, for example, so for this name, we want to know what is the address of the server that is responding to this name. First of all, we are going to use the command dig. Dig is used to make DNS queries. In this case, I'm asking dig ns. This ns is the type of the query, and in this case, it is a name server. And this dot is the root of the tree. So I'm asking what are the root name servers for the domain service. And we see a list of servers in the answer. For example, a.rootservers.net, b.rootservers.net, and so on. Let me try again. Now, we can ask any of these servers for a top-level domain. So we can choose one randomly. All of them have the same records. They are synchronized with each other, and all of them have the same list of records. But we see, for example, that there are no IPs. How does the computer find what is the IP, for example, for a.rootservers.net? It is a fixed list of IPs, because these are the root name servers. Their IPs are well known and they don't change with time. They are fixed, and every computer, every program has them baked in. So It is known that, for example, if we ask a.rootservers.net, the IP for this server is this one. Now, let's ask for the domain AL, because we want to find out user1.fs.al. The top level domain is this one, AL. So I want to know what are the name servers responsible for this domain. The name servers that give answers for names under this domain. So I'm going to ask this question, this query, dig ns al dot. And let me ask this question to, for example, m.rootservers.net. So, I'm asking this query. It is the query of type ns, name server. What are the name servers for this top level, for this domain? And I'm asking this query to this server. It can be any name server on the list. For example, I can try B or C or any other. And we see that we are getting an authority section here. And authority section means for this name server, go and ask one of these servers here. And we also see in additional section that, for example, nsx.nic.al is at this address, at this IP address. So I can ask for the subdomain fs.al to one of these name servers. All of them are synchronized and they have the same list of records. Why do we have multiple name servers for the same domain, for the same top level domain? For being robust. So if one of the servers is down, then we can go and ask the other one, for example, and the service is not interrupted. And also for load balancing, because when we ask a query, we choose randomly one of these servers, and so the load is distributed among them. So it is both for not interrupting the service. If one is down, then we can ask the other. Reliability, and also for distributing the load distribution among these servers. And let me also use this option short. Which is going to give a short answer, only the relevant records or data. Now, let me ask, what are the name servers? Dig ns for fs.al. So the name servers that answer queries for this domain, which is my domain actually. And I'm going to ask this query to one of these. And we see this authority section. Authority section means go and ask one of these, because these are the authority for this domain. So this server itself does not know does not have the records, does not answer the queries for this domain and its subdomains, but it is saying go and ask one of these because these are the authority for this domain and its subdomain. And again, all of these servers are synchronized with each other, and they have the same list of records. So it doesn't matter which one we go and ask, we will get the same answer. So now I'm going to ask now for user1.fs.al. Let's say this one. I'm going to ask this. And let me try to answer to ask an address for an address. So what is the address? So this is not a subdomain. So there are no name servers for this subdomain. User1.fs.al is not a subdomain of fs.al, but it is just an address. So now I'm asking what is the address for this name, for this name. It is not giving an answer. Why? Understand? Maybe there is no record for this one. Let's ask, for example, for okay. Now we get an answer section here because there is no record for user1.fs.al, but there is a record for this domain, wordpress1.user1.fs.al, and this is the IP address for this name. So if a browser tries to open this this URL, for example, with this name, then it is going to contact the server with this IP address. And with short, with the option short, we get just the answer. Without these extra details. So usually we don't do this step by step like what I did right now, but we can just ask for a domain and it will give the answer. And it knows how to follow these steps itself. If it does not know what is the name server of the top level domain AL, then it is going to ask to the root server, root name server, and then it is going to cache it so that next time it needs this, it does not go to ask again to the root name servers, but it knows that it can ask 1, 2, 3, 4. For this name, for this top level domain, and then it goes to ask for name servers of this one, and it caches it. And when we ask for this domain, it knows where it can ask, and it is going to ask one of them randomly. And the same thing that is done by dig tool, by this tool, is also done by the browser to figure out the address for a name server, and by other internet tools, the tools that connect to the internet. For example, if I say SSH, again, this SSH is going to figure out what is the IP of this domain, and it is going to follow the same steps or the same procedure as this command, dig.
Dashimir, I wrote a question.
Okay, let me check it. user1.fs.al is not a subdomain. Right now it is not a subdomain. I can actually show you the configuration of my DNS, but we are going to make it a subdomain later. In this lesson, I'm going to convert it to a subdomain. It is a subdomain, but it does not have its own name server. So okay. Let me try to So this is where I manage the domain fs.al. This is my domain, and I am managing it here. It is not on the VPS. It is on my real server. And I'm including here this configuration file. And in this configuration file, I am redirecting subdomains for this course. For example, this is a wildcard, star.user1.fs.al. It is redirected to this IP, which is the IP of my VPS. And for example, this is redirected to the IP of Tony, for example, VPS of Tony. And notice that I have not specified anything for user1.fs.al itself. So if I want to redirect something for these two, I have to say, for example, user1.fs.al, one dot here. Like this. So now if I make a query for this domain, then I'm going to ask this, I'm going to get this address. But because I have not specified this, I did not get an answer for this domain. However, I get an answer for example, WordPress1.user1.fs.al, etc. So And later I'm going to convert this user1 into a subdomain by including this configuration file, but right now it is commented. So now this is what I'm going to try, but I was trying to explain something else here. For example, if there are several name servers for the same domain, they have to be synchronized with each other so that their content is the same. And how do we manage this? How can we manage that all the name servers have the same content? This is done by assigning one of these name servers as primary and the others as secondary. And we make modifications only to the primary. We add records only to the primary name server, and we remove or delete records only from the primary name servers. And the secondary name servers are synchronized with the content of the primary. And when we make a modification to a primary name server, it is sending a notification to secondary name servers. It knows the secondary name servers, and it is sending a notification that there is a new content. And then name servers, the secondary name servers, are asking for a list of all the records for this domain from the primary. They get this list and replace the old list with the new list of records. And this way, all the name servers are kept synchronized with each other. And another thing is that the primary name server does not have to be public. It can be private and behind the firewall. And public are only the secondary name servers. And secondary name servers, which are public, are those who answer the queries from the client. So a client is going to ask one of these secondary name servers. And each secondary name server knows what is the primary name server. And also the primary name server knows what are the secondary name servers. And when a modification is done on the primary name server, it is private. It cannot be accessed by the clients. It is protected by a firewall for security reasons. When we modify the content of the primary, then it is sending notifications to the secondary name servers. They are sending they are making a query for the list of the records. They get the query and update the old query with the new one. And now we are going to install in our DNS, in our VPS, in our server, we are going to install a primary name server. And then we are going to use as secondary name servers some public services that can serve as secondary name servers either for free or for a small price, or maybe they can work for free up to a certain limit, and then if the number of queries is larger, then you have to pay a small fee for them. So we are going to install this primary name server in our VPS right now. So the name of the script is called NSD, and it is cloning it into this directory. Now let us initialize a directory for the container, for this NSD container. It has created this directory here. And we can have a look at the settings. And here on the settings, we see this variable secondary ns, which is these are comments. These are comments. So these are the secondary name servers that we want to use for this primary name server, and I have listed some of them that we have that I have used in the past, and they can be used also. But for this example, to keep it simple, we are going to use only these two name servers from body ns, and another variable axfr servers. These are the IPs of the secondary name servers. These are the servers who make axfr requests to the primary name server. And these are the IPs of the corresponding services. For example, this service uses this IP. So when we make a modification on our primary, which is this container, it is going to notify this one. And then this IP is going to make a request, axfr request, for a full list of records. And then our container is going to send the full list of records to this IP. And the same for this service. This is the IP for this service. Hessner also can be used, can serve as a secondary name server. And these are the IPs of body NS. It has a lot of servers. So let me try to so I'm going to customize the list of name servers here. I can use these two, the first two name servers, or all three of them. Copy. Oops, I did something wrong. Actually, I have them on the list, so let me keep on from the list only the first two. So I'm going to keep these two, and I'm going to delete the rest. Control K, and this is a comment. This one, I can delete it or I can keep it. It doesn't matter. And then from the list of IPs, I'm going to remove these ones, and I'm going to keep only the IPs of the body NS. Save. And let me try to build the container with dsmake. List of containers, it is running here, and I see that I did not have any problems with the port 53, because sometimes this port is used by some other services, but it seems that on this VPS with Debian Trixie, Debian 13, we can use it. There is no issue using this. So the container is running. And now I've built this primary container, and I've told this primary container what are the secondary. I've built this primary name server, and I've told it what are the secondary name servers. Now, I have not told the secondary name servers what is the primary name server for this domain. The domain that I want is to use is user1.fs.al. So I have to tell them that for this domain, the primary name server is this VPS. And the IP of this VPS is this one. So since I'm using BuddyNS as a secondary name server, I have to go to the website of BuddyNS and register this VPS as the primary name server for this domain, user1.fs.al. So this is buddyns.com, and what can I do here? Login. And let's say that I don't have an account. I have an account, but I will pretend that I don't have one, and I will sign up again. And I have 3 fields here: email, but I'm going to modify my email because I already have one account with this email. So I'm making a simple modification like this to the email address. And then the domain is user1.fs.al, and the master server, the IP of the master server, master is called the primary, master slave, primary secondary, or master slave. It is the IP of my VPS. Join. Registration is successful. Check your email. So the password is this one. It is sending me the password, and let me try to log in. This is my email that I used to register, and I'm pasting the password. And I'm going here to zones. And I see the domain that I registered, user1.fs.al. Primary is this IP. Submitted. This is the date of registration. Last updated on. It still has not managed to receive any records from this server. Let me try to refresh and see what happens. But before doing this, actually I forgot that I have not added this domain to the primary name server. So I installed the container for the primary name server. But if I look at the zones, there is no zone for the domain user1.fs.al. So it is just an example zone. So ds zone, I can add a zone with the command add, ds zone add, and as an argument I can give the domain of the zone that I want to manage with this primary name server. Now if I list the zones, I see this one. This is containing the records. This file is containing the records. So this is the configuration, and if I look at this secondary NS, this file that is included here, config secondary NS, it is actually listing the name servers from body NS. So these are the secondary name servers for this zone. These are being used as secondary name servers for this zone. And what else can I do? I can test. I can check. I can check the zones with this command. And the configuration is okay. Let me test. There is also this. This test subcommand for the zone. I see that I get a failure. I think it is because okay, why? I'm trying to troubleshoot. First, let me check the service NSD. So the NSD service is running. NSD is the program inside this container that manages the domain. And if I look at the logs of the system, the command test, ds zone test that we tried before, is sending this AXFR request to this container from outside the container, and it is being refused. That's why the test fails. And also the request from this IP is being refused. AXFR request from this IP is being refused. And I guess this is one of the IPs of BudDNS, which tries to get the list of domains. No ACL matches. Why no ACL matches? Let me try again dsmake to build the container again. Now it worked. So the command ds zone test, I don't know what was wrong the first time, but after rebuilding the container, now it is answering this query, this test. So this is making a test by asking a request for the list of all the records. And it is getting, this is the list of all the records from this primary name server. If BudDNS is asking a query like this, it should get the same list of records. So let me check again the logs. So and I'm going to try a refresh here. Where is it? I see no request here yet. Let's try to refresh the page. And it says serial none. The serial number is received from so it still is not managing to get a request, or maybe it is not rushing. Although I am saying refresh, it is going to make a refresh at another time later, maybe. Because this is just a free service and they don't want to be overloaded. But also, there is another thing that I need to make, because I have to delegate this subdomain from the main domain. So the main domain is fs.al, and this is a subdomain of this domain. And I have to delegate from this domain to these name servers, to the secondary name server. So Basically, this domain fs.al should say that for queries related to user1.fs.al, go and ask bodyns with this IP. Bodyns in this case is the secondary name server. If we had some other secondary name servers, then it should say for the queries related to user1.fs.al, go and ask this and this and this and these servers. These are the responsible servers for giving you the answer for these queries. So I have to make this modification on my primary domain fs.al. So let me go and make it. I manage the domain fs.al on my server, and I showed you this file before. So I have to uncomment this include here and comment this line. So by uncommenting this, I'm including this configuration. And in this configuration, there are this delegation. So let me delete the third one because we just used the first two only, or I'm commenting it. So it says that this is an NS record. NS record means name server. So it basically says that for queries related to this domain, go and ask this name server, and also go and ask this name server. So these are the two name servers. It is delegating the responsibility. So it does not ask, if I ask WordPress1.user1.fs.al, this name server does not have the responsibility to answer, but it says go and ask these other name servers for this subdomain. It is a delegation. So let me save this. And I also have to, whenever I make some modifications to the name servers, I have to update the serial number as well. So I made a test today. This is this is fourth. So I'm increasing the serial number, and I'm doing it by keeping the date like this: year, month, day, and then this is a serial inside the day in case I modify it multiple times in the same day. So I'm increasing the serial number here, save, and I can say ds notify. So this primary name server is sending notifications to the secondary name servers that there are some modifications in the serial and in the content of, but the content doesn't matter. If the serial number is different, then the secondary name servers are going to request an update. If the serial number is the same, they don't request an update. So after making this modification, the delegation of the domains, I can stop this with Ctrl+C, or I can do a ds restart the container, and when the container is restarted, it will also notify the name servers, check for any modifications, any possible modifications. I see that I had some requests from I see in the logs this request. So let me check again here, refresh here. Okay, now it has managed to contact the server because we see the serial. This is a very old serial, but we are going to update it later. And I think now the setup is finished. And I think we are done now. Since it is saying this okay here and okay, and usually I get a no response here, but this is fine. So we are done with the configuration of our name server. Now let's continue with the example of WireGuard. So we want to build a virtual LAN. A virtual LAN means that this client can communicate with this client and this client as if they are in a LAN, but they will access the internet with their normal gateway. So this is going to access the internet as usual, not through the WireGuard VPN. This one is going to access the internet as usual, and this one is going to access the internet with its own gateway. But they can communicate with each other as if they are in a LAN. So this is why they are calling it virtual LAN. And this is accomplished by this WireGuard server in our VPS, in our server. So this client does not have a public IP. This client does not have a public IP. So how can they communicate with each other through the internet? This happens through the WireGuard tunnels to the WireGuard server. So let's install the WireGuard server first. So we have this VPN one here. Let's initialize another directory, ds init WireGuard. I will call this one VLAN. We see that there are some default settings. It has found out the public IP and has modified settings properly. It is using a random WireGuard port, etc. But now we can use this command ds setup. For this use case, for building a virtual LAN, we can use this command ds setup LAN, and then we give what addresses we want to use for the clients in this LAN, and then we list the names of the clients that we want to include in this LAN. And this command is going to generate configurations for all these clients. maybe I should use another domain here. I forgot to build the container. Let me build the container first, because the container is not running yet. And now let me use this command again. So what this command dsSetup does, it modifies the settings properly for this use case for building a LAN, and it is creating configurations for these clients that we are listing here. So let us have a look at the settings. We see these rooted networks, and this is the network that we gave as an argument to the dsSetup command, to the setup command. And these rooted networks means that when we build a WireGuard client between the client and the server, only the connections to this network will be routed through the WireGuard VPN. The other networks will be routed through the default gateway, through the normal gateway. So if we try to access the internet, we should go through the normal gateway. If we try to access one of the computers in this, one of the addresses in this network, then it should go through the VPN connection, through the WireGuard tunnel. And this is not necessary, but maybe this should be commented. Anyway, allow internet access? No. So this virtual private, this VPN is not being used to access the internet through the server, but it is used to access the clients with each other. And this setting, client to client, yes, this allows the clients to access each other, to communicate with each other. And there is also this setting, keep alive period 25 seconds. So every 25 seconds, the client is sending a keep connection alive package. Otherwise, the WireGuard connection will expire, and if a client wants to communicate with another client, the connection of that other client has already expired, so it cannot access it. But with this setting, the WireGuard tunnel will be kept alive all the time. So we can access, the client can access each other anytime. So we have the configurations, these three configurations for the clients, and now we have to transfer these configurations to the clients and check whether they can communicate with each other. I have one client here. We installed WireGuard in this client last time. Okay, Thomas, we will continue for 5 more minutes until we finish this example, and we will close it. We have this configuration from the first time, And there is this WireGuard connection. We can keep it or we can shut it down and add another one. It doesn't matter. So I'm calling this configuration vlan1.conf, and I'm going to copy the configuration from this file. Just a simple copy paste. And let me test this. So I have now this connection, VLAN1, and this interface has this IP. Now let me go to the second client, which is on the other window here. I will copy the configuration of the second client. And now I'm bringing up this WireGuard configuration, and this is this IP. Now I will try to ping from this IP, the IP of the other client, from this client, the IP of the other client. And I see that they are communicating with each other. And we will make some more interesting things tomorrow with this example. So I'm stopping here, and we will continue with this example with some more interesting thing. And this interesting thing is that we, for example, can access through this virtual LAN. We can access the server, the VPS, securely.